is Daniel Oetikam. I'm a Microsoft Data Platform MVP and the creator of Tabular Editor. And today I'm going to talk to you about Tabular Editor's scripting engine. So let's head over to my presentation. Right, so today's presentation is called Deep Dive into Tabular Editor's scripting engine. And this presentation will cover an introduction to scripting with Tabular Editor. I'll show you some more details on the Tom wrapper and Tabular Editor scripting libraries. We'll go into the script engine architecture, the custom actions functionality, and finally we'll touch upon the best practice rule syntax. Right. So first of all, when it comes to scripting, I like to compare the various tools and techniques we have available in terms of how productive we can be using these tools, and also what the learning curves looks like. So in my opinion, it's clear that SSDT and Power BI Desktop, the standard tooling for building tabular models, is the least productive tools that we have in our disposal. Now, on the other hand, they are certainly the tools that are most easy to learn, with the largest amount of available documentation and communities and so on, especially when it comes to Power BI Desktop and learning to build a tabular model. Now, Tabular Editor, on the other hand, it has some learning curve, but I would wager that it is definitely also more productive. You can, of course, be even more productive if you just write everything in code from scratch, taking the 100% programmatic approach to building tabular models using Tom or TMSL. But of course, the learning curve for that is much larger, especially if you start with no or only a little programming experience. However, if you use scripting in Tabular Editor, I would say that you get sort of the best of both worlds in having both Tabular Editor UI and scripting available. It also makes the learning curve a little smaller, since you can just learn Tom as you go, and Tabular Editor can help you do that. I have a slide here with some more details, but it just basically covers everything I just said on the productivity versus the learning curve. But again, keep in mind, this is just my subjective opinion of these various techniques and tools. So what can we actually do with scripts? So basically, scripts are used mostly for automating tedious tasks, repetitive tasks that you may come across while modeling. You can also use scripts or actually write scripts in order to reuse them across different models. So in order to do the same tasks on different models. It's sort of similar to macros in the Office tools. I believe that scripts really unlock the full productivity potential of Tabular Editor, and you can just consider some of the examples I give here, like automatically creating relationships between tables based on column and table names, or auto-generating explicit measures from columns, auto-generating time intelligence measures, that sort of stuff. You can find a lot of examples of these scripts on the Tabular Editor wiki. Specifically, there's an article here called Useful Script Snippets. And just to give you a quick example of one of these scripts is this one here. Best practice dictates that we should always create explicit measures from the columns, numeric columns in our model, instead of relying on implicit measures. So over here you see Tabular Editor fired up. I've connected to my AdventureWorks model, and let's go to the internet sales table. You can see it already has some measures, but just to show you how quickly we could generate some of these measures from scratch, consider that we have a number of numeric columns here. We have the discount amount, extended amount, freight, gross profit, and so on. And in reality, all of these columns should actually be hidden, and we should set the summarize by property on these columns. So summarize by, which is this one, it's currently set to default, and we should actually go ahead and set it to none, so that we inform the client tools that it should not allow any summarization on this column. That's sort of the best practice anyway. But instead of going through all of these columns one by one and doing this, it's much easier to just copy in the script and then basically just multi-select the columns from the hierarchy over here. I can multi-select columns by holding down Shift or Control, and then basically just run the script. We'll see what happens is immediately we get 6 new measures. some of discount amount, some of extended amount. Each of them have a DAX expression that's just a simple sum. And at the same time, we can see that now the measure has been hidden. And we could even expand this script even further by setting the summarize by property to aggregation function none. Let me just quickly undo the changes made by this script, and then select the columns once again. Our quantity, set amount, tax amount, and we can run the script one more time. Yeah, the syntax is aggregate function, so let's try again. And here we see the 16 columns created, and now when we look at the columns, we can see that now the summarized by property have been set to none, which is a best practice for a numeric column. Of course, it doesn't really matter since the column is hidden, but anyway, now you know how to do this. So you can find many other examples of what you can use scripts for online. For the remainder of this session, I'm going to focus more on how the scripts actually work, the syntax, the libraries you should be aware about, and so on. So the way it works is you write and execute the scripts directly inside Tabular Editor, as you just saw. You use you hit F5 to execute the entire script, or if you select a portion of the script, you use F5 just to execute that specific portion. As we just saw a moment ago, Tabular Editor even tracks the changes that the script applies to your model. So if an error occurs, the changes will be rolled back automatically by default. Or if you manually want to undo the changes performed by the script, you can just use the Control-Z, Control-Y shortcuts as usual. You can open and save scripts directly from the interface using the little buttons in there. Or you can save the scripts as something called custom actions that we'll see later on how that works. Finally, you can drag and drop objects from the Explorer tree into Tabular Editor's scripting window to easily generate a C# object reference to that particular object. So what this means basically is if you want to get a reference to a particular object, you just drag that object into the script editor and you get a fully qualified C# reference to that particular object. So in this case, we have a reference to a measure. If I just want to output the name of that measure on the screen, I can just write something like this, and sure enough, we get that measure's name in the output. All right, so some important concepts that is worth investing in and learning about if you want to really get the most from scripting. C# is of course the first one, since the scripting in Tabular Editor uses the C# programming language. So if you know a little about the syntax and the keywords and so on of C#, that's definitely an advantage. If not, don't worry too much. You should be able to learn most of the basic stuff just by using some of the examples available. Another interesting concept is something called LINQ, a language integrated query, which is a language feature of C# and a set of methods that we use oftentimes when working with collections of objects. Now, in the tabular model, many of the objects that are in there are actually object collections. So the collection of tables on the model, or measures on a table, or columns on a table, and so on. All of these are collections. And as it turns out, you will use these collections a lot when you're writing scripts. So having some knowledge on how to use LINQ is an advantage because it makes it easier to write the code that you need. Now we also have TOM, which is the Tabular Object Model. This is the API provided by Microsoft to programmatically work with the tabular model. This is the API that holds all of the model metadata that represents it as C# objects and classes that you can work with. So the model itself, tables, columns, measures, and so on. And all of the properties that we can change. So the name of a measure, or an expression, description, all of these properties are object properties within the TOM. And basically, when you're writing a script, you should think as if you are manipulating the TOM object model directly. Now that is not entirely true, because there's actually an extra layer on top of the TOM, which is called the TOM wrapper, and this basically acts as an interrupt between Tabular Editor's UI. So every time you do something in Tabular Editor's UI, so if you create a new measure, or if you rename a table or so on, this operation actually happens through the TOM wrapper. And that's because the TOM wrapper is what gives Tabular Editor its undo redo support, and it also handles stuff like deployment, serialization, and so on. When you are scripting things, you are also scripting against the TOM wrapper library. The TOM wrapper is the way the API looks is very, very similar to the TOM, with a few exceptions. We'll get into those later. And there's also some convenience methods that makes it easier to add a new table or add a new column and measure and so on. In fact, you may also use the TOM wrapper library as a standalone DLL. If you're writing your own custom .NET applications, you can go ahead and use this library even without the Tabular Editor UI. Lastly, we have the Tabular Editor.scripting library, which is an internal library used within the Tabular Editor executable to provide some additional scripting capability that is not necessarily related to TOM. So, for example, this is a library that lets us interact with what the user has currently selected in the Tabular Editor Explorer tree, and it also provides a wealth of helper methods that are also very useful when you are writing a Tabular Editor script. We'll get back to those later on. As I said, if you're new to C#, don't worry. There are many examples of scripts you can use online. If you want to learn more about C# itself, there's also plenty of resources available online, and the links that you see here on the slide are my recommendations. All right, so TOM wrapper and the Tabular Editor scripting library. As I mentioned before, Tabular Editor uses both TOM and the TOM wrapper. When you're scripting, you're basically just scripting directly against TOM wrapper, but it's important to know that TOM wrapper basically just is as the name indicates, it's a wrapper around the TOM library itself. Now, the TOM library is this hierarchical representation of the data model's metadata. You see the picture here on the right side of the screen, basically indicating how a tabular model looks like from a metadata perspective. This hierarchy is normally represented as JSON, at least if you open a model.bin file, or if you take a look at a TMSL script, then you will see a similar structure just represented as JSON. And the TOM is what allows us to manipulate this structure. Now, TOM wrapper itself exposes an almost identical set of objects and properties as the TOM. So if you are familiar with the TOM, you will find it easy to work with the TOM wrapper library as well. And then it adds some additional functionality. As I mentioned before, this is functionality needed by Tabular Editor for change tracking, events and so on inside Tabular Editor's UI. For some tasks, TOM wrapper also offers a more convenient API with some helper methods that makes it easier to use. And there are also a set of abstracted interface for common object properties. So if you have stuff like tables, columns, measures, all of these three objects can be hidden. There's a property called isHidden on tables, columns, and measures. And therefore, TOM wrapper introduces an interface called iHideable object that you can use to refer to any object across the tabular object model that can be hidden. So stuff like that is built into the TOM wrapper library to make it easier to work with the TOM programmatically. Now, if you take a look at the TOM documentation, if you follow this link here, you can see that it's defined in the Microsoft Analysis Services tabular namespace, and this holds all of the object properties. So, for example, on a data column, which is an object within the TOM, we have properties like alignment, alternate off. These are all described here. We have the description property. We also have a data type property, and the data type itself uses this enumeration, so you can see here what things are called. Earlier on, when I made the script with the explicit measures from columns, I used the aggregate function enumeration used by the summarize by property to specify the aggregation, and I used the none property and so on. So that's all documented there, and TOM wrapper is basically, I would say, 90% identical to TOM, so you can use the TOM documentation for most purposes, but there are a few exceptions. So, for example, in the TOM, all objects derive from a metadata object or named metadata object if they are objects that have a name. In the Tom wrapper, it's slightly different. The base object is called tabular object, and the base named object is called tabular named object. So there are a few differences, but for all practical purposes, it's mostly the same, and you can use the Tom documentation for your scripting. So there are some general principles you should be aware about when working with Tom. So for example, all properties that have plural names represent collections of objects. So for example, you have model.tables or table.measures or hierarchy.levels. These collections are all statically typed. So tables will be a collection of table objects, measures will be a collection of measure objects, and so on. And all of these collections can be indexed by object name in a case-insensitive manner or by ordinal index. In addition, all of these collections have a contains method that you can use to perform a case-insensitive search within the collection based on the object name. And there are also some setter methods available so that you can set a property on all of the contained objects at once instead of having to iterate it. It's just all convenience methods. Let me show you how it works. So for example, if we start with the model object itself, which sort of represents the root of the hierarchy here. The model object has a collection called tables, which basically represents all of the tables inside the tabular object model. And now this collection, I can use the typical properties or methods that act on collections. So for example, if I use count and we output that, we just get the count of tables in our model, 14 in this case. But of course, I could also use the link method. Link methods, for example, there's a method called first that we can just use to get the first table in the collection. And if we output that, we just get a representation of this particular table. In this case, it's the customer table. But we can of course also index into the table collection by specifying the name of a particular table that we want to look at. So if I wanted to look at the employee table, I can just type the name of that table, and then we get all of that table's properties. So if we just output it directly like we did before. So in this case, notice that I deliberately specified a lowercase e, even though the table is actually named with an uppercase. When we output this, you can see we get all of the properties for the employee table. So that is sort of the way we normally get a specific object within the model. And indeed, when we drag an object from the tree, this is indeed what Tabular Editor does for us. It references the employee table, and then it references the columns collection on that table because we dragged in a column. Specifically, it was the department name column. And then one last step here is that it actually casts the column to a data column type object. And that's because in a tabular model, you have several different kinds of column objects, and all of them sort of derives from a base abstract column class. The column class itself has properties like hidden, description, name, and so on. But if you want to get specifically to properties that are related to a data column, such as the source column property, then you have to cast it to a data column object. On the other hand, if you have a calculated column and you drag this in, then you can see Tabular Editor is going to cast it as a calculated column. Because one of the properties that a calculated column has that the base column class doesn't have is the expression. So the DAX expression for the calculated column. So this expression does not exist. This property does not exist for a data column object. So that is why we have this distinction. And knowing all of this stuff, if you know Tom, then that will help you understand how it works in Tabular Editor scripting as well. Now, if we want to search for a specific column, if we want to know whether a specific column is in a table or in a collection, we type the name of that collection, and then we can use the contains method. So if I want to know if there is a last name column within this collection, we can just type this, and you can see we get an output of true, because yes, indeed, the employee columns contains an object called last name. Lastly, we have these setup properties. So if we want to set multiple properties, or if we want to set a property on all of the columns at once, instead of iterating through the collection of columns, we can just specify the common property, in this case description, and just assign whatever value we would like. And then when we run this, you can see Tabular Editor tells us that now we have applied 30 model changes to a model. And indeed, there will be one change for each of the 30 columns on this table. And this change specifically is that now we've set the description property to XYZ. All right. In addition, all of the objects in Tom wrappers, they have methods that know about how to add a child object to that object. So specifically at the model level, we have methods that knows how to add a child table or a child calculated table or row and so on. All of these can be automated. So if we want to add a table, then actually we get a reference to that table back. So let's put that in a variable, and we can output the name of that new table after we add it. So if we run this, we get the output, which is just the name that we provided up in line 1. And you can see indeed we now have this new table as part of our object model as well. Now if we go to a particular table, so in this case new table, then we will have some other methods available. For example, we will have a method available for adding a measure. And this method we can see in the intelligence what parameters to use. We can see we need to use name, expression, and we can also specify display folder if we want to. These are all optional. So in this case we can write add measure, and then just put something like 1 + 1, and it'll go into the expression, and even a display folder if we want to do that. And then run this. Sure enough, you will see the table now has new folder, new measure folder located in this display folder, and this measure will also have this expression assigned as we specified. So all of that is just, you know, a one-liner of code in Tabular Editor. Very, very easy to use. All right. So the next I want to talk about is the Tabular Editor scripting library. Because this is a library that enables some interaction between Tabular Editor's UI and the script itself. Specifically, we have an object in the library called UI tree selection, and this object is the one that enables us to know what the user has currently selected in the Tabular Editor model tree. So you can access this object through a global static property called selected. And it basically just represents a collection of all of the objects that are currently selected. So for example, if I write selected count, and let's go with the selected direct count and output that, then we just get a value indicating how many objects are currently selected in the tree. And you can see that if I select multiple tables here, it just says, hey, now we have 3 objects selected. The reason we have a property here called direct count is because of display folders. So for example, if I move some of these measures into a display folder and I just select this particular folder, you can see the count, the direct count here is still 1. However, if I change this to count instead of direct count, then I actually traverse all of the objects within that display folder and even within subfolders of that display folder. So, in all respects, when you make a selection like this, where you select the display folder, well, for most cases, the display folder in itself is not really interesting, but the collection of objects beneath that display folder are definitely interesting from a scripting point of view. So that is why we have this this approach here. So, for example, if we know that we want to consider a specific measure and the user selected just one measure in the Explorer tree, we can type selected.measure and then we can output it to get some more details on that. So right now I selected more than one object of type measure. Specifically, I selected all of these measures, which is equivalent to just selecting the display folder. But if I select a specific measure in the tree and run the script, we can see now we get this measure up on the screen. If we want to work with multi-selection, we can type S to get a plural, and you can see in this case we're going to get a list of all the measures that are currently selected. So if I select 5 measures, in this case, it's just going to show us a list of these 5 measures that I selected. If I select both measures and columns, in this case, we are still only going to get the measures outputted because that's what we asked for. And if I only select columns, then we're just going to get an empty collection. So if we type measures that count, in this case, we're just going to get 0. So that is how you can work with object collections and currently selected objects in Tabular Editor. Now there's just one thing to be aware about, is that for cultures and perspectives, for historic reasons, if you type selected perspective, then you're not going to get the perspective that is currently selected in the Explorer tree. And you can see here, if I output it, we're going to get an error saying that no perspective is currently selected in Tabular Editor. And what this means is that we didn't select any perspective up here. So that's an exception to the way that objects on the selected property normally works, because when you write selected perspective, it actually refers to the perspective that you chose in the drop-down button. So here we go. So in case you wanted to know exactly which object has been selected in the tree, you would use the plural form, which basically represents all of the perspectives that are currently selected. And if you only want to work with a single one, you can use the link method called single, because single will always assume that you made a single selection. So in this case, it will just give me reseller operations. But if I select multiple perspectives, I'm going to get an error saying that the sequence contains more than one element. Or if I didn't select any perspectives, I'm going to get another error saying that the sequence contains no elements, because I specified that I want to look at perspectives only, right? So that just to be aware about that. All right, so in addition, so we already saw that we have these two top-level objects, the model itself, which represents the entire tabular model, and then the selected object, which represents whatever we currently selected in the UI. But in addition to that, the Tabular Editor scripting library also has a lot of other useful methods for doing various things in our script. For example, we've already seen many times that we can use output to just output anything, basically. And output can literally take any object as a parameter. If we use an integer value, we're just going to get that value on the screen. But if we put something like a table in here, we're going to get all of the properties for that table. And as you saw, if we put some collection of objects here, well, then we're just going to get them output in a list. But that's not all, because output can also take stuff like a data set or a data table. And that is very useful if we use one of the other helper methods that is available called evaluate DAX, which will let us execute a DAX expression on the analysis services server, and we can output that expression as well. Oh, by the way, output can be called both as an extension method, which is the syntax I show here, or we can just call it as a regular method using this syntax. These two syntaxes are completely equivalent, so it's up to you to decide which one you like the most. But running the script, we can see we get a 3 outputted, and in this case it's a DAX expression that was evaluated by analysis services and then returned. It doesn't have to be a scalar expression. We can put a top n here, and then specify table name to get the first 10 rows of that table. And our output method can handle that as well by displaying the result in a grid. So there are many options here for making interesting interactive scripts. Some other interesting examples here are: there's a custom action method that you can use to execute another script that was previously saved as a custom action. There's a format DAX script. So basically, if you have a DAX expression like this, and you call the format DAX expression on it, it will send a request to the DAX formatter web service so that the DAX expression will be properly formatted, in this case by adding spaces between the operands here, which is the best practice according to DAX. And now, using this technique, you can easily format all of the DAX expressions across all of your model measures. In fact, let's just write that script right now. So for each m in model.allMeasures, which is shorthand to iterate through all of the tables across all of the measures across all of the tables on the model, and then for each m we want to set the expression to format DAX m expression. So just like this, we can so if we take a look at a particular measure here, in this case let's just change this a little bit. Let's get rid of this from our previous demo. So now we can see that the DAX expression for some internet sales that does not contain any spaces or anything like that, so it's not using the best practice for DAX formatting. But now if we run the script, it'll just take a little while because it needs to make a web request to the DAX format or web service for every single measure in our model. That'll take a couple of seconds to complete. And then basically once that finishes, it should be around any second right now. So here we go. We see that now we have 29 model changes. And going back to the measure we saw before, we can now see that nice little spaces have been added here according to best practices when writing DAX code. So basically calling the format DAX method here is equivalent to hitting the little format DAX button that we have in the UI. And there are many more helper methods like this. Convert DAX for converting between US and non-US decimals and separators. Export properties and import properties for exporting object properties to a tabular separated format. And then some new additions recently were the execute DAX function that we just saw, or evaluate DAX. We also have the execute command method, which you can use to execute any TMSL or XMLA command, for example, in order to do a refresh of the data in analysis services. Just please be aware that while this is executing, and generally while any script is executing in Tabular Editor, the UI will be completely frozen. So just keep this in mind before you try to refresh a table that takes several hours to complete. Because in that case you will just freeze up Tabular Editor while this is executing, and you may also encounter some timeout issues. So what I'm saying is this is mostly useful for executing small TMSL scripts that do not take a long time to complete, for example, in order to recalculate a calculated table or some other small stuff like that. Lastly, I added some new methods recently that gives us even more interactive options. So just imagine that you are creating a script that will apply time intelligence logic to a model, and the first thing you want the developer to specify is which table in the model that represents the calendar table. Now, of course, you could have something like setting a variable at the top of the script where the user needs to specify the name of the calendar table, but you could also make it interactive by using this new select table method, because when you run this, it will prompt the user to select a table, and then that table will be stored in a reference in the calendar date variable in this case. So if we do something like calendar date name, or I could do something like use selected like this. So first we select the table, and then the script tells us that we selected the date table, right? So we have some more options here, and this can also be used with columns or any other kind of object in the tabular object model. So once we have the calendar date table, we can make a call to select column, and then we specify calendar date as a parameter because we just want the user to specify a column on the calendar date table. So let's call this calendar date key, and then basically when we run this, so first we decide which table we need, and then we get a list of all the columns in this table. So date key in this case, and just for fun, let's do something like evaluate DAX values. And then since calendar date key represents a column, we can get its a DAX reference to that object by writing something like this. And let me just put info here first of all, just to see if this works. So let's take date key, and sure enough, here we've generated a DAX expression for getting all of the values in this column. So instead of writing info, let's write evaluate DAX. Let's output the result, and sure enough, when we do this, now let's go with the product and color, and then we get a table that shows us all of the values in this particular column, right? So you can probably come up with many interesting scenarios that use these features. I leave that as an exercise for the community, but just now you're aware that these methods exist. Right, so with that said, let's dive a little bit more into the architecture behind the scripting engine of Tabular Editor. Specifically, what happens when you actually execute a script within Tabular Editor. So there are a number of steps that Tabular Editor performs in order to execute the script. So first of all, the script itself is tokenized. I run a simple tokenizer that simply splits up the string into individual keywords and operators and so on. Because that allows me to extract any assembly references, external assembly references, or using statements that are in the top of the script. I'll get back to those in a short moment. And it also allows us to add line numbers to method calls such as output and info and so on. So going back to the example I had earlier, if I write something like info, hello world, and we execute this, you can see that Tabular Editor actually informs me here that this info method was executed on line 8 of the script. And the way it knows that is because before the script is executed, Tabular Editor sort of implicitly adds the line number as an additional parameter to this method call. And that is, again, thanks to the tokenization and step 3 in this compilation process. Step 4, prefixing global method calls is also something that happens because in reality methods such as info and output and evaluate DAX and so on are all just static methods on a static class called script helper. So basically Tabular Editor, before compiling the script, Tabular Editor will transform this line of code into this line of code, and as you can see they do the same thing. And that's just in order to make it easier and more compact to write script code, so you don't have to include the script helper every time you want to call one of these methods. And then finally, the script is encapsulated within within this script body, within a static method. So basically, there's a static method called execute that takes the model and UI tree selection parameters, which will then be available for the script, and then the script is sort of embedded within this method. And then finally, Tabular Editor includes references to the Tom wrapper library, to Tabular Editor.exe, to the Microsoft Analysis Tabular DLL, which is the Tom, and a couple of other references, and also any external references that you add. For example, if you put a hashtag R at the top of your script, that allows you to add other .NET libraries, or even your own custom DLL, custom assemblies. You can add them this way. And then finally, the resulting code is compiled using C# code provider. And as of the newest version of Tabular Editor, you can actually configure Tabular Editor to use the Rustling compiler instead. This is if you are interested in using some of the new C# language features. So there's a link here in the slide you can check out if you're interested in that. So I mentioned we can include external assemblies using the hashtag R style. And if any of you have been working with Azure functions, this is sort of the same sort of syntax that you're using to reference external libraries in an Azure function. In addition, we can also shortcut namespaces using the regular using syntax. So just by writing using.system.io compression, then you don't have to qualify objects or classes from within the compression namespace every time we reference them in the code. And as you can see, this still compiles just fine. So we can just reference the object names directly. If you want to reuse code, so if you want to create your own method that you can reuse, you would typically need to declare a lambda. Because there's no way to actually declare a method body using the script syntax. So what you would do is you would do something like define a new action, call it say hello, and this takes a string as an input, and then for the body of the lambda itself, we can do something like info s, and this would then allow us to execute this by saying say hello need to remember a semicolon after this expression. So this is sort of the way where you can reuse blocks of code in a reusable manner, simply just by using the C# lambda expressions and declaring them as actions or funcs. Alternatively, if you feel that you want to dive a little bit deeper into the scripting engine, you can also choose to hack the script engine. The way you do this, keeping in mind that your script gets embedded into a script that looks like this, a method. If you keep that in mind, well, then you can just choose to exit the global script method by adding an additional curly brace, and then you can define your own methods and even your own classes that you can reuse, just as long as you remember near the end of the script to open a curly brace again to match the one that we stole early on in the script. Then everything will still compile just fine, and you will be able to instantiate your own custom classes in the script. So, changing paces here a little bit, I want to show you a little bit about the custom actions functionality in Tabular Editor. So I already mentioned previously that it's possible to save scripts as custom actions. The way you do that is you simply click the little plus button up here at the top of the script window, and that will show this UI where you will specify a name for the custom action, an optional tooltip, and one or more collections on which your custom action will be active. So basically saying, okay, when we integrate the custom action in the UI, what kind of object do you need to click in order for the custom action to show up and be available? So for example, if I create a new action here called, let's just do something like selected table name. Or you know what? Let's make an even more interesting example. Let's evaluate DAX selected table DAX object full name to get a DAX reference to that object, and then just just to be safe, let's put that in a top n. So we generate a DAX expression that looks like this, and then we output that. Then whatever table we select, we are going to get the top 10 rows of that table. So date, customer, and so on. So if we want to be able to invoke this script from the UI, we can choose to save this as a custom action, and we call this get show top 10 rows, and we just indicate here that this custom action should only work when we invoke it on a table, and then we hit OK. And now you'll see whenever we right click on a table, you'll see that we have this now as a custom action. We can click, and immediately we get a preview of the data in this table. That's pretty neat. So we've basically extended the functionality of Tabular Editor with our own sort of custom action functionality here. All of these actions are stored in a JSON file locally on your machine, and they are compiled once you start up Tabular Editor. And this JSON file, just to provide a few more details, it's an array of objects, and objects have the following properties. They have a name, as you saw. They have an optional tooltip. They have this valid context string, which is basically a comma-separated list of the kind of objects on which the action will be visible. Then they have an enabled property, which indicates whether or not the action is enabled. By default, this will just be set to true, but you can customize it if you like. And then finally, it will have an execute string, which contains the script itself. So let me show you how that looks. So here I have on my local app data Tabular Editor folder, I have the custom actions.json file. If I open this file in a text editor, you can see what it looks like. And sure enough, the newly added show top 10 rows action that we just created is right here. Here's the script that gets executed when we run this action. Here's the valid context. And you can see enabled right now has just been set to true. So one thing to be aware about here, so right now I use the singular form here, so selected table, which means that this action only really works when I select only one table. So that means if I multi-select multiple tables, I can still execute the action because I'm still considering tables only, but I'm going to get an error since the selection contains more than one object of type table. So I want to customize my action a little bit, by specifying that instead of just always the action always being true, I want to provide a C# expression here that indicates under which circumstances the action will be enabled. So what I will do is I will type selected tables count, or actually I think I will say selected direct count equals 1, so that in this way this will only work when I have selected one and only one object. So now I'm going to save my custom actions.json file, and I'm going to restart Tabular Editor. You can see here in the corner it says that 15 custom actions were loaded. And now when we connect to AdventureWorks, we should see that if we select multiple tables, the script will not be available, the custom action will not be available. But if we only select a single table, we will see that now we have the custom actions show top 10 rows option available. Right, the last topic I'm going to talk about is the best practice analyzer, another feature that's integrated in Tabular Editor. This feature allows you to define your own best practice rules, which are scanned continuously in the background to check that your model lives up to certain best practices or naming conventions or whatever you decide. And these rules are defined using something called LINQ dynamic expressions. Now the syntax itself is quite similar to C#, but not exactly the same. What you should be aware about is that these rules are always defined for a set of object collections. So what this means is, if I go into the best practice analyzer and I consider any rule on my model, so let me just take this one, for example, do not use floating point data type. Let me just copy it into the local model, because then I can edit the rule so we can see how it looks like. You'll see this interface. Most of this is just some metadata about the rule, but then we also have this drop down where I specify what kind of object collections I want the rule to apply to. In this case, it's just all of the column collections in the tabular model, so calculated columns, data columns, and so on. And for each of these columns, I want to see if I have any columns where the data type is set to double, because this would mean that it's a floating point data type, and that is something that I want to avoid. So in this case, I want the rule to highlight those, and sure enough, if we bring up the best practice rules interface, so in fact I don't think I have any floating point data types in this model. Now I could try to just take one of these, freight for example, and I could change the data type to double, and now we should see that that the best practice analyzer indicates that reseller sales has this issue that we should probably fix. And the way it works is basically that the best practice analyzer is scanning the model using these expressions. So let me once again, since I canceled this a moment ago, so let's go in and look at the expression once again. So this is an expression that is being evaluated for each model, each object in the collections that are specified here. And if the expression evaluates to true, well, then we report that object as being in violation of the best practice rule. Now the syntax for the best practice analyzer, as I said, it's quite similar to C#, and in fact it's using the same Tom wrapper object model as you're using when scripting. But what you need to be aware about is that you are basically just specifying the inner part of a C# lambda expression without the input parameter. So for example, the example that is shown on the screen here, where we have a rule that applies to calculated tables and tables, and the rule expression is name.starts with fact and is visible. Basically what this translates to is the corresponding C# lambda that you see here. So it's basically just iterating through all of the model tables and then evaluating this lambda expression for every single table. In addition, there are some other properties and objects in the dynamic LINQ syntax that you should be aware about. For example, there's a keyword called it, which refers to the current object. So normally I can just reference any property on a table or any property on the object just by typing the name of the property. But if I had some kind of nested, so for example, if I type table here, I'm actually referring to the parent table of the current column. So if I want to do something like table columns any and then do something like sort by column equals it. So the purpose of an expression such as this is to, for every column, I also want to iterate over every other column on the table in order to see if any of those columns have a sort by column which is equal to the outer column, the one we're iterating. So this is maybe a bad example, but the idea is that we have some keywords we can use in order to refer to certain objects within the nested iterations that are being performed here. Lastly, you should be aware that all enumerations are represented as strings. So, for example, in C#, a data type would be written a little differently since it's an enum data type, but in dynamic link you need to treat it as a string. And also some of the operators are a little different. You use the word and instead of the double ampersand symbol that you use in C#. You use or, not, and so on. And also when you write dots, it's basically non-conditional. So in this example, if table had been a null object, you wouldn't get any errors in this case because it's performing a null check whenever you put the little dots in here. So it's just a couple of things to be aware about when writing the dynamic link expressions. And that actually concludes the deep dive on Tabular Editor's scripting engine. I hope you enjoyed it, and I hope you have asked some good questions along the way. If you didn't get the answers you were hoping for, please reach out to me. We'll discuss, or you can feel free to create an issue on the Tabular Editor GitHub repository if you have any questions or anything like that. And with that, I just want to wish you happy scripting and enjoy Tabular Editor. Thank you.